we are to write the secant of theta in terms of the sine of theta in quadrant 3. So here we have a circle, and in quadrant 3 we have an angle that we can call theta, terminal side in quadrant 3, and then we can put a vertical to the x-axis and then pull that triangle out, and we'll have this side will be on the x-axis, this side will correspond to y, and then we have our hypotenuse, which is the radius of the circle. So let's pull that triangle out and look at it a little bit. So this will be the same triangle, just written a little bigger. So we have a right angle here, and this then would be our reference angle, theta sub r. Now in the third quadrant, the sine and the cosine would be negative. But let's remember how we write the sine and the cosine in terms of x, y, and r. The sine of theta will be y over r, or in other words, opposite over hypotenuse. But it will be negative in the third quadrant. The cosine of theta, x over r, adjacent over hypotenuse. The tangent of theta would be y over x. Cotangent of theta would be x over y. Secant of theta would be r over x. And cosecant of theta would be r over y. Now again, remember that sine and cosine would both have negative coefficients. The tangent and the cotangent would both be positive because y and x are both negative in the third quadrant, and so that ratio, y over x or x over y, would be positive. Secant and cosecant would both be negative because r is always positive and x and y are both negative in the third quadrant. Now, let's think about some things here. We know from the Pythagorean theorem that x squared plus y squared would be equal to r squared. Now, if we were to divide both sides by r squared, here's what we would have. We would have x squared over r squared plus y squared over r squared equal to 1. We could write each of these quotients as a square. So in other words, we could write it as x over r squared plus y over r squared equal to 1. But x over r would be just the cosine. So we have the cosine square of theta plus, and then y over r is the sine. So we would have the sine square of theta equal to 1. This is usually written as sine square theta plus cosine square theta equal to 1, and it is the first Pythagorean identity. This is true no matter what the value of the sine and the cosine. The sine square plus the cosine square would always be equal to 1. First Pythagorean identity. Okay, now we're going to use that in a minute. We're also going to use another fact, and that is the fact that the secant is just the multiplicative inverse of the cosine. So in other words, we can write the secant of theta, which is r over x, as 1 over x over r. Remember, when we divide with fractions, we invert and multiply, so these two things are the same. But x over r is just the cosine, so this would be the same as 1 over the cosine of theta. So here's another identity that we have. This is called an inverse identity, and it is the secant of theta is equal to 1 over the cosine of theta. Now, let's solve this Pythagorean identity for the cosine. So here's what we'd have. We would have the cosine square of theta equal to 1 minus the sine square of theta when we subtract the sine square from both sides. Then, taking the square root of both sides, we would have the cosine of theta would be equal to plus or minus the square root of 1 minus the sine square of theta. Now it would be positive if we were in the first or fourth quadrants, since the cosine is positive in the first quadrant. This would be negative if the terminal side of theta was in the second or third quadrants, since the cosine is negative in those quadrants. Now we're in the third quadrant, so what we're after here then is that the cosine would be the opposite of the square root of 1 minus the sine square theta. So here, writing the secant now, in terms of the sine, we can write this as 1 over the cosine, which in this case is going to be minus the square root of 1 minus the sine square of theta.